Hey guys, look, there's the chamber. Try to open it.
It's not opening!
It's not working.
The Chamber of Secrets isn't opening. What is happening?
You must demonstrate your complete understanding of a function.
What function?
Hey, look! We need to solve this.
Okay, let's solve it as fast as we can to open up the Chamber of Secrets. Let's go, guys.
Let's go.
Let's put in the factored form. So, the factored form is y is equal to x plus 3 squared minus x power 2 plus 6x minus 10. And that's the factored form. We found this form through long division, broken down into 3 different steps. Okay, let's see if it works now. Still not open! Oh my gosh! 1.
Right now, let's find a symmetry. If the function has an even symmetry, just for example, this function, it has a parallelogram, and okay, so this function is for this, and it's equal to whatever it reflects on the y-axis. These two graphs look same. So it's also, if you can see this, and it has even symmetry, and if it's odd, just for example cubic graph, when you reflect it over the y-axis, it will look like this. If you reflect it over the x-axis, it still look like this. So if you see this characteristic, and it has odd symmetry. Now let's find the symmetry. If the function has an even symmetry, just for example, this function, it has a parallel, and this function is it's equal to whatever it reflects on the y-axis. These two graphs look same. So it's also, if you can see this, and it has even symmetry, and if it's odd, just for example cubic graph, when you reflect it over the y-axis, it will look like this. If you reflect it over the x-axis, it still look like this. So if you see this characteristic, and it has odd symmetry. Now we need to prove it as an even odd or needed function. And we can see it's different from this one, so it's not it doesn't have an even symmetry, and it doesn't meet the odd symmetry characteristic, so it's not odd. Therefore, the symmetry is not even or odd, so it's neither. After finding the symmetry, now let's see is it open now. Oh no, it's still not open. Tony?
1.
Okay, so the long run behaviors as limit x approaches infinity, as x goes towards infinity, it would be negative infinity. And the limit of y as x approaches negative infinity would be positive infinity. But we really don't need to graph this in order to find the long-run behaviors. We can look at the function y equals negative x to the power of 5, and we can see that the largest degree is odd. We actually don't need the graph to tell the long-run behaviors. If you look at the function, we can see that the largest degree is x to the power of 5. If it was just x to the power of 5, it would be like this. But because it's negative, it's flipped, so the long-run behaviors would be shown like this. This time it should open. No! Wait, what?
You must find the intercepts.
Aline.
So we're going to try one last thing. Now we're going to try to find the intercepts. So, as you can see from this function in its factored form, it's pretty easy to find the intercepts. Because up there, if you were to plug 0 into the equation, you'd find that there's an intercept here at 0, 0, and as well at 0 and when 0 is plugged into the equation, you also find that there's an x-intercept at negative 3. So in this rough sketch, you can see what it would look like. That's what it would pass through. And from then sketching this, you can easily see that even when y is equal to 0, x is equal to 0 too. So it passes right through the origin. And I can prove that easily by just making x 0 to find the intercepts. So then we can imagine when y becomes 0, it is also 0. So these are the intercepts for the function. There's two x-intercepts, one at negative 3 and one at 0. And there's one y-intercept, right through the origin. Now, let's go see if the door is going to open now. We'll try together. Use your magic to open the door. Now, Camille, check if it's opening. Now, the real adventure can begin. Into the Chamber of Secrets we go.